Now we are going to consider Fourier series of arbitrary period t is equal to L, and based on that we will solve all these examples. So now first let's have example number 1. Obtain Fourier series of f of x is equal pi minus x raised to power 2 divided by 4 with the interval that is 0 to 2 pi. And previously we have seen same interval 0 to 2 pi, but function was f of x is equal x. But here we can observe that length is nothing but p is equal to L is equal to pi. So we will get the L is equal pi. But when we apply that here Fourier series formula, so it will be here f of x is equal a0 by 2 plus summation starting from 1 to infinite an cos n pi x divided by L, but L is equal pi, so pi will be eliminated. And the same concept here, what was actual, that is sin n pi x divided by L, but if I put L is equal pi, so pi will be cancelled out, so this is going to be sin nx. So that we will keep in mind. So now let's have a look at the first a0. So a0 is what? Integration. Now a0 is equal 1 divided by L, but L is equal pi, integration from 0 to 2 pi f of x into dx. But if I suppose to consider f of x is equal pi minus x square divided by 4, so in that case I can take 4 common as a constant quantity, so we get integration that is 0 to 2 pi minus x square dx. But whenever it is required, we will use this formula, integration f of x raised to power n, and derivative of the function is there. So what we can assume that equal to fx raised to n plus 1 divided by n plus 1, and that formula we will use here. So whenever we consider that concept, so product derivative of the pi minus x is what exactly minus 1, but minus 1 is not there, that means I have to put minus 1 here. So we get minus 1 divided by 4 pi and pi minus x raised to power 3, because power will be added here. So 2 plus 1, that is 3, and that divided by 3 over y to y, that is 0 to 2 pi. But if I put x is equal to pi and x is equal 0, so we get this one. But after simplifying you will get this one, and final a0 will be pi square divided by 6. Now let's have a look at the another an. 1 divided by L, but L is nothing but pi. Lower limit is that is 0, upper limit that is 2 pi. F of x cos nx dx. But function is what? Pi minus x whole square divided by 4 cos nx dx. But when you apply a Leibniz rule for the integration, so first one 4 I just take outside, and this is what exactly our u, and this is going to be v. So u is there, integration of the cos, that is sin nx divided by n, then derivative of the pi minus x square, that can be written as 2 times pi minus x into minus 1, and then again integration of this one minus cos nx divided by n square, the derivative of this one, that is going to be only 2, because minus derivative of this one is going to be minus 1, but minus plus 1. So ultimately what we are going to get, this is a plus 2, and already plus 1 is there because alternate terms are there, and integration of the cos is what exactly sine, but minus is already there, and so what we are going to get, sin nx divided by n cube over y to 1, that is 0 to 2 pi. Now we are going to put here x is equal to pi. So what we will get, cos to n, sin to n pi, and sin to n pi is what exactly 0. If I put here x is equal to pi, so what I am just going to get, cos to n pi, and cos to n pi into minus plus, and x is equal to pi, so ultimately we get minus, and 2 is there, again minus is there, so ultimately we get plus 2 pi cos to n pi divided by n square. And again sin to n pi is what exactly 0. But when we consider another limit, so instead before that we will put minus sign, and here if I put x is equal 0, so sin 0 that is 0, so we put here 0, and cos 0 that is going to be 1, but minus 1 divided by n square is there, and again x is equal 0, so what we are going to get, minus plus, and again minus is there, so ultimately this is minus plus, and minus is there, so we will get the minus. So that you can see 1 divided by 4 pi, and again this is minus is there, so we can say minus into minus, so it is going to be plus. So we will get the 2 pi divided by n square plus 2 pi divided by n square, and we will get 1 divided by n square. Similarly, you can find the bn. I'm not going to spend for this example. Also, you can understand each and every step I have mentioned here. So based on simplification, you will get bn is equal 0. After putting all these value in the Fourier series, you will get this Fourier series. So f of x is equal pi square divided by 12 plus summation n is equal 1 to infinite. This is going to be 0. So we get cos nx divided by n square. And f of x is equal what exactly? Already we have assumed that pi minus x divided by 4. But this is power square. And this is equivalent to this one. Now, if I suppose to consider any period p is equal to L, so in that case what will be? This is our standard formula. Already we have done this one. But now let's have a look at the example. Suppose you have given that the f of x is equal to x minus x square with the interval that is 0 to 3. That means length is equal what? So p is equal to L is equal 3. So always we can find L is equal, that is 3 by 2. So whenever we consider the formula, f of x is equal a 0 by 2 plus summation starting from 1 to infinite n cos n pi x divided by L plus bn sin n pi x divided by L. This is our standard formula. But if we replace L is equal, that is 3 by 2. So what I am just going to get? Denominator goes to denominator, numerator. So we can say 2 times n pi x divided by 3, and here we will get the sin 2n pi x divided by 3, and here this will be our final Fourier series. But for that we have to determine the a0, where a0 is equal 1 divided by L integration c to c plus 2L fx dx, and this is our standard formula. L is equal 3 by 2, integration limit of integration, that is 0 to 3, fx is equal to x minus x square dx. But when you integrate, so what we are going to get? 2 times x square by 2. 2 will be cancelled out. X cube by 3 is that. But if I put x is equal 3, so what we are going to get? This is 9 minus 27 divided by 3, and x is equal 0, that is going to be 0. So we are going to get 9 minus 9, and that is what? Exactly 0. So we get a0 is equal 0. But if we consider an is there, again we can assume that 0 to 2L. Otherwise, instead of that, we will consider general formula c to c plus 2L. But when we put here limit L is equal, that is 3 by 2, and limit of integration, that is 0 to 3, and f of x is equal this one. So in that case we can apply Leibniz rule. U is there, then derivative, and then double derivative. First one, integration of the cos, that is the sine, and then we will write again integration, and again we will do the integration. But when we put first upper limit, so what we are going to get? X is equal 3 will be eliminated. So we get sine 2n pi, and sine 2n pi is 0. Cos 2n pi into 3 divided by 3 will be eliminated, and we will get the cos 2n pi. So cos 2n pi is there. But this can be written as minus 9 divided by 4n square pi square. But if I put x is equal 3, so 2 minus 6 is there. But again, x is equal 3, so 3 will be cancelled out. So we get the sine 2n pi, and that is what? Exactly 0. Minus, but when we assume that the second limit, so before that we will put sign minus. So x is equal 0 here, so it is going to be 0. X is equal 0, that means cos 0, and minus 9 divided by 4n square pi square, and x is equal 0 is here, so we get here minus in bracket 2 minus 0, and in bracket minus 9 divided by 4n square pi square cos x, and if we put x is equal 0 here, so sin 0, that is going to be 0. But after simplifying, you will get this one. But when you take LCM, so you will get this one, and final you will get minus 9 divided by n square pi square. Similarly, you can see bn, already I have represented all the terms clearly, so you can try to understand. You will get bn is equal 3 divided by n bar. So therefore the Fourier series can be represented. This is our standard formula. Now just it is need to replace a0, an and bn. But initially we have assumed that a0 is equal, that is 0, that was we have derived. And this is an is minus 9 divided by n square pi square, bn is equal 3 divided by n pi. This is our final answer. Thank you.